All right, welcome. This is our third video in our bonding unit, and this one will be an introduction to covalent bonding. And you're going to need page 25 in your notes open. That's where we're starting, page 25. So, covalent bonding. In covalent bonding, what's important to recognize, we only have nonmetals. We don't have any metals involved. And nonmetals will not transfer their electrons to other atoms because they want to achieve a stable octet, right? But they have 5, 6, 7 valence electrons. So they're close to getting the full 8, which means that they are not interested in giving up any that they have at all. They're going to keep all the electrons they have, and they want to add more. So they are not going to give away any of their electrons to any other atoms. So because of that, because there is no transferring of electrons, because they're simply keeping what they have and they're not interested in giving any away, we actually wind up not having any charges or ions involved. There are no charged particles involved in covalent bonding because what we have instead is a sharing of valence electrons between nonmetal and other nonmetals. And the reason that they share is like, okay, so I have 5 and you have 5. If we pool our resources together, we can both have a stable octet around our outermost shell if we share 3 apiece. So the big point is that instead of transferring and having ions, now we're sharing electrons, and we're only looking at nonmetals. So if we have multiple nonmetals in a compound, we know we have covalent bonding, and we know we're going to have this sharing of electrons. A molecule, by definition, does not mean any random small particle that you want it to be. No, in fact, a molecule, by definition, is a group of atoms that's held together by covalent bonds. So when you say molecule, you have to specifically be talking about something that has covalent bonding, meaning something that has multiple nonmetals in it. The term molecular is a word that we're going to see a lot in this unit. And molecular is simply an adjective that's used to describe something that has covalent bonds. So when you see the term, which of the following is a molecular substance, that's basically another way of saying, hey, which of the following has covalent bonding? They mean the exact same thing because molecule means covalent bonds. So molecular means covalent bonds. So we sort of have two words to discuss that. So that the molecule contains covalent bonds. I would not say that an ionic compound is a molecule. That's wrong because it doesn't have covalent bonds. I would say it's a formula unit. It's that small thing. It's slightly different terms. So, covalent bonding. What do we have? We have a sharing. Oh, this is so huge. This is such an enormous point. Put lots of star circles next to this. Sharing of valence electrons between nonmetals. Really big. That's our key verb, right? It's a different verb than we had in ionic, where we had transfer of electrons. Now we have sharing of electrons. Molecules are electrically neutral. And that's a big point. There are no ions involved, so as a whole, they don't carry any sort of charge. And the ratio now with covalent bonding is not about the transfer of electrons, but it's instead about how many electrons are needed to complete the octet. Right? How many molecules do you need so that everything is going to, how many atoms do you need so that everything is going to get an octet? Properties of molecular compounds. Again, enormous. This is a big point. We have to, and we think back to our salt sugar lab, right, where we had this difference between ionic and molecular compounds. So most of the molecular compounds are going to be in the liquid phase or the gaseous phase. So they're not solids anymore, right? They're liquids, they're gases. They're very soft. The attractions that hold together ionic compounds are much stronger than the attractions that hold together molecular compounds. They have very low melting points, low boiling points, and they do not conduct electricity. At all, ever. They don't do that. The reason that they don't do that is because there are no charges. There are no charges involved in covalent bonding at all, right? There's no charge. It's just the sharing of electrons. So we don't have a time where we're going to have moving charges. So just a couple practice questions. First one, which characteristic is a property of molecular substances? Now remember, molecular substances, this is a phrase that means something that has covalent bonding. So we want to look for the thing that is a property of stuff with covalent bonding. Good heat conductivity, no, no, no. They don't conduct at all. Good electrical conductivity, nope. They have really poor heat conductivity and poor electrical conductivity. Low melting point, oh yeah, that's it. Because they don't have high melting points. They have very low melting points. That goes along with them being liquids and gases. They tend to evaporate easily. They tend to melt really, really easily. Next question, and chemist performs the same tests on two homogeneous white crystalline structures, A and B. Results are shown below. And then it asks us, if we just kind of look at the possible answers here, notice we have options that both are ionic, both are covalent. A is covalent, B is ionic. A is ionic, B is covalent. So let's have a look at the table and sort of bear that in mind. So with solid A, we have melting point, solubility, and conductivity. And we haven't really talked about solubility, so let's focus on the melting point and the conductivity. Melting point of A is very high, and it is a very good conductor when it's in aqueous solution. Both of these things point to A being ionic. Those are properties of ionic compounds. High melting point, and they conduct when they're in aqueous solutions. So I'm going to eliminate choice 2 because A is not covalent, and likewise choice 3 because A is not covalent, it's ionic. And then we have B. Again, looking at melting point and electrical conductivity, melting point is low. Okay, so we have a low melting point, and conductivity, it doesn't conduct at all. Again, this is stuff that tells me that it's molecular, i.e. it has covalent bonding. So A is ionic and B is covalent, so I'm not going to choose choice 1 because B is not ionic, but A, nope, I did that backwards. No, yeah, 4. No, 4 is right. A contains ionic bonds, B contains covalent bonds, right? Correct choice is choice 4. And then lastly, which of the following solids has the highest melting point? Okay, so we're thinking about properties, right? High melting point. This is a property of ionic compounds, not molecular. And how do we recognize ionic compounds? We recognize ionic compounds because they're metals and non-metals together. That's how we know we have an ionic compound. So really we're just going to evaluate all our options and find which one is the metal and the non-metal. Choice 1, hydrogen and oxygen. Hydrogen is a non-metal, so is oxygen. So that is a molecular compound that's covalent bonding that does not have high melting points. B, sodium is a metal, oxygen is a non-metal. Okay, that's ionic, so that works. Just to look at the other options, 3, sulfur and oxygen, those are 2 non-metals. So that's, again, that's covalent, that's not going to have a high melting point. And 4 is carbon and oxygen. Again, those are 2 non-metals. So the correct choice is choice 2. So that's the end of the video notes. So we'll be working with this. We'll be doing some other work in class tomorrow.